On a clear morning, the highest point on Earth projects a deceptive stillness. The morning light catches the prayer flags, and the summit appears as a peaceful, achievable destination. But simply existing at this altitude is an ongoing biological emergency. The air here contains only a third of the oxygen found at sea level. With every breath, the human cardiovascular and respiratory systems push to their absolute limits just to keep the brain functioning. To survive this massive exposure, climbers rely entirely on the weather window. This is a brief period, usually in May, when the jet stream naturally bends away from the peak. For a few days, the hurricane-force winds vanish, granting safe passage along the exposed ridges. The problem is that atmospheric modeling at 29,000 feet is fragile. Forecasts can fail, and when the window slams shut, it rarely gives hours of warning. This chart visualizes the immediate meteorological warning signs of a failing window. We see a sudden plunge in barometric pressure, followed instantly by a free fall in ambient temperature. Within the death zone, above 8,000 meters, these warnings signal an immediate priority shift. Success is no longer measured by the summit, but by how quickly a climber can drop altitude before the storm arrives. The storm's arrival is marked by a sensory blackout. Fast-moving cloud cover slams into the mountain face, swallowing the environment in a matter of minutes. High-speed winds then scour the ridges, churning up loose ground snow. This creates a true whiteout, a condition where light scatters in every direction, reducing visibility to literal zero. In this void, the human brain loses its ability to orient itself. Without a horizon or physical landmarks, climbers cannot distinguish up from down. Stepping off a sheer drop or unhooking from a safety line becomes a terrifyingly easy mistake. As the storm intensifies, the winds rapidly escalate past hurricane force, exceeding 100 miles per hour, initiating a severe thermal assault. This thermal cross-section shows the physics of wind chill at extreme altitude. At these velocities, moving air physically strips away the thin layer of radiant warmth clinging to the skin, dropping internal body temperatures in seconds. Once that radiant heat is gone, biology fails. The ambient cold penetrates the skin, crystallizing the fluids inside cellular tissue. Severe frostbite sets in on any exposed surface within minutes. The biological crisis extends beyond the body and into the gear itself. While the cold crystallizes human tissue, it simultaneously turns drinking water to solid ice and locks critical oxygen mask valves shut with frozen condensation. Even for climbers who manage to reach the temporary sanctuary of the high camps, the danger remains extreme. The kinetic energy of the storm turns those camps into impact zones. Hurricane force gusts shred nylon tents, removing the climber's only barrier against the wind. Airborne rescue is mechanically impossible. Extreme atmospheric disturbances generate violent downward wind currents that overpower rotor lift capabilities, grounding all flights. These same disturbances disrupt satellite communications and scramble radio frequencies, severing the link to base camp. The physical shelters are destroyed. Airborne rescue is mechanically grounded. The communication lines are dead. The trekkers are now entirely isolated in the most hostile environment on Earth. When the low-pressure system finally moves off the peak, the immediate violence ends. Morning light breaks across the valleys, revealing the changed landscape. For the survivors, the psychological framework of the expedition is rewritten. The ambition to stand on the summit is gone. It is replaced by a single, agonizing imperative: get down. Moving downward demands a physical toll. The body is no longer equipped to pay. The climbers must navigate steep, technical descents while running on zero caloric reserves, depleted oxygen cylinders, and heavily damaged gear. And the terrain itself holds secondary dangers. High winds lay down layers of unstable fresh snow. This powder masks the crevasse fields, covering deep, fatal gaps in the ice that were clearly visible just days before. Modern mountaineering utilizes millions of dollars in advanced engineering, elite physical training, and cutting-edge meteorology. But all of these tools can only mitigate the mountain's baseline conditions. When those conditions inevitably break, an Everest storm strips away every technological advantage. It proves that survival on the highest peak in the world requires knowing exactly when to surrender to the mountain.